Hello everyone, in this video, let's learn 3.5 rational functions and their graphs. Let's do some review. Determine the restricted value of the domain of the following functions. In chapter 2, we have learned how to decide the domain of the function. We have two kind of restrictions for the x. So the first one we say if in the function we have a fraction, for example, we have 2 over x, and all the bottom is not equal to 0, that's the domain of the function. A second restriction, if we have the even root of an expression, for example, I still put the x in the square root or fourth root or sixth root is greater than or equal to 0. Let's see the following two examples. The first one, is that a fraction? Yes, it is. It has top and bottom. That means the domain of the function f, the bottom 2 minus x is not equal to 0. Then we can solve for the x. Both sides I can add x, so I can isolate the x. 2 is not equal to x, or x is not equal to 2. On the number line, I can skip x equals 2. Highlight other area. So the domain of the function is from -infinity to 2. Union 2 to infinity. Next one, the bottom is not equal to 0. X squared minus 6x plus 5 is not equal to 0. So we have solved that equal to 0. And then each factor equal to 0. But this one is not equal to 0. We can factor this trinomial. Each factor is not equal to 0. I'm using AM method. Because leading coefficient is 1. M is 5. Find two factors. Addition can make a -6, -1, -5. So let's factor it. X minus 1, x minus 5 is not equal to 0. That means first factor is not equal to 0. Second factor is not equal to 0. We can solve these two inequality, add 1 both sides. X is not equal to 1 plus 5, x is not equal to 5. On the number line, I can skip these 2 points, 1 and 5. So the interval notation of the domain is from -infinity to 1. Union 1 to 5. Union 5 to infinity. All right. So what is a rational function? Rational function is the fraction. So it has a top, it has a bottom. The top is the polynomial, and the bottom is also polynomial. Okay, so f of x can be written like n of x. This is the polynomial, and the bottom is d of x. It's also a polynomial. Why we're using n and d? N means numerator polynomial. D means denominator polynomial. And the denominator is not 0 because the bottom is not 0. If the bottom is 0, the expression is undefined, or the function is undefined. Let's see one example. Graph the function f of x equals 1 over x. This is a fraction. This is a rational function. How to graph it? In previous example, we have learned how to graph the linear equation. It's a straight line. We can find 2 points. It can decide the straight line. But now we cannot use straight line. The rational function, they are smooth curve. So we need to plot more points, then use smooth curve, connect them. For example, you can make some charts. Here is x, here is f of x, and input some value for the x. You can put some negative values, -100. Then the f of x is 1 over -100. That's -100. negative 50. Oh, sorry, why I'm saying 50. So 50, I have negative 1 over 50. You can plot more points. You can also plot some positive points. That's 100, 1 over 100, and 50, 1 over 50. So it takes us a long time to plot a lot of points there. I can use new technology. Let's use decimals.com. Let's input 1 over x, 1 divided by x. It shows us the graph. It's beautiful curve. And we see some 2 special lines in the graph. So right curves, they are the graph of the function. But how about x equals 0 and y equals 0? X equals 0 is a vertical line. I don't know how to graph it on decimals.com. I think I see the button. No, this one, sorry. I think I see the pen somewhere, but it doesn't matter. Ignore that. So vertical line, x equals 0, and horizontal line, y equals 0. So these 2 lines, we call them vertical asymptotes and horizontal asymptotes. Vertical asymptotes means you see the graph all the way going up, getting very close to the line x equal to 0, and the bottom curve getting very close to the x equals 0, but never have intersect, never touch it. Horizontal line, y equals 0, you see the line is getting very close to it, but never touch it. We call this horizontal line, horizontal asymptotes. All right, let's come back to the lecture notes. So we know how to graph the 1 over x is smooth curve. It's not very perfect. Another side, it doesn't have sharp corner. That's too smooth curve. Let's see the definition of vertical and horizontal asymptotes. If f of x approaches infinity or approaches negative infinity, a approaches a, x approaches a, then the line x equals a is a vertical asymptotes. For example, I have a vertical asymptotes. I use dash line. There's no straight line. Okay, we use the dash line represents x equals a. If the function, the y's value approaches infinity, and then x value, this point, getting closer to, so the graph is getting closer to x equals a, x value is approaches a, but never equals a. Y's value is approaching infinity, so this is the vertical asymptotes. And also we have other cases. For example, the graph approaches this line this way. So what y's value, f of x, approaches negative infinity, and its x value also approaches x equals a. And also have other cases like this, getting close to it but never touch it. So x equals a. And another case, we are having the graph approaches the vertical line this way. So these are the vertical asymptotes because the graph is getting closer to it. So look at the graph, these 2 examples. X equals a is the vertical line, and the function f is getting closer to it, and then y's value approaches negative infinity, x value approaches a, but why we have a plus? Because plus means approaching it from the right side of the a. So you see the graph is approaching it from the right side of the a. And the second example, the f of x approaches this vertical line from the left. So f of x approaches negative infinity and x approaches a minus. A minus means approaches from the left. All right, let's see the horizontal asymptotes. If f of x approaches b as x approaches infinity or x approaches negative infinity, then the line y equals b is horizontal asymptotes. For example, I have horizontal asymptotes as a y equals b, and the graph could approaches this way or approaches this way, y equals b, or approaches from this way, approaches from this way. So from the example, f of x approaches f of x approaches the line y equals b. X approaches infinity because it's all the way moving to the right, and y's value approaches b. And second example, as the function approaches the line this way and x approaches infinity, y's value approaches b. All right, how to find the horizontal asymptotes and the vertical asymptotes? Let's see. Asymptotes of rational function. Let f be rational function given by f of x equals n of x divided by d of x. N of x, d of x are have no common factors. If they have common factors, so they will be cancelled. For example, 2 times x plus 2 over x plus 2. Top and bottom cancelled. We have function equals 2. That's not a rational function. Make sure they have no common factor. Number 1, the graph f has vertical asymptotes at the 0 of d of x. Okay, so let d of x equal to 0. We have learned that the domain said the bottom is not equal to 0, then x is not equal to some specific value. But now we're looking for the vertical asymptotes. Let the bottom equal to 0 and x equal to that number. Maybe it's not 0. So a question mark, and the function's x will never touch this x, will not equal to that x, but it's approaching it the x equal to that value. Is that confusing? It is not. It is not. All right, let's see. Let's make the bottom function make bottom polynomial equal to 0. Solve for the x. That x is the vertical asymptote. Sometimes we have more vertical asymptotes. Okay, let's see. First example, find the vertical asymptotes of f of x equals x divided by x plus 4. So the bottom equal to 0, x plus 4 equal to 0, minus 4 both sides. X equals negative 4. So x, so on the graph, x equals, okay. X equals negative 4. Okay, this is positive 4. So this is the vertical asymptote. So we can say VA, that's vertical asymptotes. Find vertical asymptotes of the function f of x equals x divided by x squared minus 9. So vertical asymptotes means the bottom equal to 0, x squared minus 9 equals 0. We can factor it using the conjugate formula. X squared minus 3 squared equal to 0. X plus 3 times x minus 3 equal to 0. First factor equal to 0. Second factor equal to 0. So we solve these two equations, x equals negative 3, x equals positive 3. We have two vertical asymptotes. All right, let's see next part. We're looking for the horizontal asymptotes. How to find the horizontal asymptotes? We can express the f of x with the numerator polynomial and denominator polynomial. So maybe, for example, the f of x equals 2x squared plus 3 x minus 4. The bottom is x cubed minus 2x plus 3x minus 5. For example, the top one is a polynomial, bottom one is also a polynomial. And can you tell me what is the degree of the top one, top polynomial? Is 2, because the leading term, the x carries the greatest power. So this power is the degree. And the bottom one, what is the degree? Leading term, the x carries the most power. This power is the degree. So the degree on the top is 2. The degree on the bottom is 3. Now we are comparing. So degree here is m, degree here is n. We need to compare the top and the bottom degree to decide the horizontal asymptotes. If the bottom one carries the more degree, has more degree, then the horizontal asymptotes is 0. For example, I have f of maybe we just use this example. The bottom one is 3, the top one is 2. So 2 is less than 3. That means the horizontal asymptotes y equals 0. We have also learned the definition of horizontal asymptotes. So x approaches infinity, or x approaches positive infinity or negative infinity. The y's value approaches b. So y equals b is horizontal asymptotes. We can use this definition and plug in x equals 0, equals very huge number, like approaches infinity, in the equation, in the function, and to decide what is the y's value. For example, if I plug in I don't know what is a very big number. For example, I say x equals trillion, maybe more than trillion. So put the x in the function f of trillion equals, on the top we have 2 times trillion squared plus 3 trillion minus 4, and the bottom is trillion trillion cubed minus 2 trillion. Why? I should have a squared, trillion squared, minus 3 trillion minus 5. Here's plus. So let's simplify this. Compare with the trillion squared. The 3 trillion minus 4 is nothing. So compare with the trillion cubed. So minus 2 trillion squared and plus 3 trillion. It's very tiny. So on the top we have 2 trillion squared. And the bottom we have 3 trillion cubed. Squared and the cubed can be cancelled. Oh, not cancelled, sorry. So top one is trillion squared, bottom one, I can cancel out the trillion squared to the bottom. So we have 2 over trillion. So if 2 over trillion, that's a huge number at the bottom, approaches 0, because 2 is too small and the trillion is too big. So the ratio approaches 0. So y approaches 0. So y is equal to 0 is the horizontal asymptotes. So if you think the explanation is so tedious, you just use the definition here. If the bottom, so if the top degree less than the bottom degree, horizontal asymptotes, y equals 0. All right, let's see 2 examples here. This one, they gave us the g of x equals 3 divided by x minus 2. What is the degree on the top? On the top, we only have the 3. And the degree on the top is 0. Because I know that the x variable carries the degree. And here, the degree is 0. So x to the 0 power is 1. So here, we only have the 3 left. But you must know that x is raised to the 0 power. so the degree is 0. And the bottom degree is 1 because x is x to the 1. So the bottom degree is 1, top degree is 0. That means we're having the first case, n less than m, horizontal asymptotes is 0. So if you use the horizontal dash line represent y equals 0, that's horizontal asymptotes. And second example, the function f of x equals x divided by x squared minus x minus 2. The top degree is 1, the bottom degree is 2. That means we have horizontal asymptotes 1, horizontal asymptote 0. You can have dash line represent y equals 0. All right, let's see next example. If we have n equals m, the top degree equals the bottom degree. The horizontal asymptotes y equals the ratio of the leading coefficient. So what's the meaning of that? For example, here f of x equals 2x minus 1 divided by x. The top degree is 1, bottom degree is 1. That means the horizontal asymptotes equals leading coefficient on the top is 2. Leading coefficient at the bottom is 1 because just look at the constant in front of the variable. The top is 2, the bottom is 1. Then the ratio is 2. That means y equals 2 is a horizontal asymptote. You see this horizontal line. And second example, the top degree is 2, the bottom degree is 2. They have the same degree, so y equals the ratio between the leading coefficient 3 over 1, because 3 is before the x squared and the 1 is in front of the x squared, so the ratio is 1. Sorry, the ratio is 3. So y equals 3 is a horizontal asymptotes. You can also plug in the huge number for the x and find for the y. So for example, this one, I plug in the trillion because I know that the definition of horizontal asymptotes, plug in the huge number in the function as the x and define the y's value. So we have 3 trillion. You can plug in the value more than trillion. 3 trillion squared divided by trillion squared. Minus 4. Minus 4 is nothing. So top and bottom canceled. We have 3. So y approaches 3 or y equals 3 is horizontal asymptotes. All right, next one. If the top one is more than the bottom one, the degree, I mean, there's no horizontal asymptotes. For example, the h of x equals 4x cubed divided by 2x squared plus 1. The top degree is 3. The bottom degree is 2. So there's no horizontal asymptotes. You see, if I graph the function h of x, is all the way going up, all the way going down. There's no cap, no bound. That means there's so the graph will not approaching to a horizontal line. It's all the way going up. There's no cap, so there's no horizontal asymptotes. You can also plug in the use the definition to find the horizontal asymptotes, because I can plug in huge numbers. H of trillion equals 4 trillion cubed over 2 trillion squared. The top and bottom do the cancellation. Oh, there's a plus 1, but compared with the trillion, 1 is nothing. So the top we have 2 trillion cubed, and bottom is trillion squared. I know that cubed squared can be cancelled. So here we have 1 left. The top we have 2 times trillion. 2 times trillion, that's a big number. And I cannot say use a specific number to represent this y's value. So there's no horizontal asymptotes. If there is a horizontal asymptotes, the y must converges to a specific number. It's not something like an infinity or 2 times infinity. All right, let's see. Find any horizontal asymptotes and vertical asymptotes, if any. So horizontal asymptotes, we use the 3 rules, and the vertical asymptotes, bottom equal to 0. So let's see, vertical asymptotes first. Bottom equal to 0, minus 5 both sides, x equals -5. Horizontal asymptotes, compare the degree top and bottom. The degree on the top is 0. You can put n equal to 0, m equals 1, because here is 1. M is, the bottom one is greater. That means y equals 0. Second example, the bottom equal to 0, find vertical asymptotes, plus 1 both sides, x equals 1. And then compare the top degree and bottom degree, then decide the horizontal asymptotes. They are the same. They both have the degree 1. What's the meaning of that? Y is the ratio of the top leading coefficient and bottom leading coefficient. That's 3 over 1. That is 3. So we found the horizontal asymptotes. And next one, the bottom equal to 0, find the vertical asymptotes. X squared minus 4, is that a conjugate formula? Yes, it is. X plus 2 times x minus 2 equal to 0. First factor equal to 0, second factor equal to 0. We are having 2 vertical asymptotes. They are -2, x equals positive. And looking for the horizontal asymptotes. Horizontal asymptotes compare the degree top and bottom. They have the same degree, so y is the ratio between 5 and 1. So horizontal asymptotes is -5. All right, we will talk about how to graph the rational function in next video. If you have any question, please let me know. Okay, have a good one.